Hello students, so welcome to Dr. Shorab's classes. As you know, we are solving this UPSC mathematics paper, this optional paper 1 of 2021. So in the previous video, we have solved this 6A. So we are solving this parts of 6, question number 6. So in this particular video, we will solve this 6B. Okay, it's of section B, and you can see that the question is given that solve the equation d2y dx2 plus tan x minus 3 cos x dy dx plus 2y cos square x is equal to cos to the power 4x, and you have to completely by demonstrating all steps involved, right? So it is already given that d2y dx2 plus tan x minus 3 cos x dy dx plus 2y cos square x is equal to cos to the power 4x. So let us take this equation number 1. So this equation is in the form d2y dx2 right plus px dy dx plus q of x y equal to r of x. So here px is nothing but this tan x minus 3 cos x, and qx is we have 2 cos square x, right? And what is rx? Yeah, sorry, rx is also there. So rx is cos to the power 4x. So let us solve this equation 1 by changing the independent variable x to the new independent variable z, where z is a function of x, and we can write that z is equal to f of x, this fx, say, right? So then we have dy dx is equal to dy dz dx, right? So we have d2y dx2, so it can be written as ddx of dy dx. So here we can write that this is ddx of dy dz and dz dx. So we have to show that all the steps that are involved. So from here you can written is write it as, so this is d2y dx2, as simple as that. So here we have dy dz, right? So yes, so from here dy dz d2z dx2 plus dz dx ddx of dy dz, right? So from here it is d2y dx2, so we have this already dy dz, then it is d2z dx2 plus of dz dx, and it will be then dx, we can write d of dz, simply dy dz, and we have this dz dx, right? So here we can write it as d2y dx2, which is equal to dy dz, and it is d2z dx2 plus of dz dx square and d2y dz2. So now from 1 is equivalent, now we have given this equation 1, so 1 is equivalent to this. So we have dy dz d2z dx2 plus of dz dx square, and it will have d2y dz2 plus tan x minus 3 cos x dy dz, and it is dz dx, right, plus 2y cos square x, which is equal to this cos to the power 4x as given. So this is similar to this, so we can write over here, so this remains the same. Okay, so this is p of x and this is q except y. Okay, so this is q on the red marked area, and we have this cos 4 is r. So there is p of x, qx and rx. Say now we have this, so we can write it in this manner. So we can do this as, so dx dz dx square d2y dz2 plus of d2z dx2 plus px, okay, dz dx, so take it common as dy dz, so plus q of x y equal to rx. So from here you can simply write it as d2y dz2 and divided by so this is plus, and we have d2z dx2 plus px dz dx by this dz dx whole square. Okay, so this whole of dy dz plus as we have this q of xy y by d dz whole square dz dx whole square, and equal to it is r of x by dz dx whole square. Now we can do one thing, that, so let us take this, let us choose z, so we can do that qx, so this part let us take this as a constant. Suppose this constant equal to 2, say, so we have this 2 of cos square x by dz dx square is equal to 2, right? So from here you can get dz dx is cos x, and from here you can get z equal to sin x. Okay, so this is equation number 2, and we have got this equation number 3. So we already have this dz of d x is cos x, right? So from here we can do, so if you do the double derivative, it will be d2z dx2, which is nothing but equal to minus of sin x, right? So d2z by dx2 plus px dz dx is equal to minus of sin x plus tan x minus 3 cos x, so which is equal to, if we solve this, it will be minus of 3 cos square x, because sin x and minus sin x and plus sin x will cancel out. Okay, now 2 is equivalent to, so from equation 2 is equivalent now, So we have this d2y dz2 plus of minus 3 cos square x by cos square x, it is dy dx. From equation 2 you can see, okay. So it is dy dx, that is the in place of p we have right, and it is simply 2 cos square x by cos square x, it is y, and it is cos to the power 4x by cos square x, right? So from here we can write that is d2y dz2 plus it is minus 3 because cos square will cancel out, so minus 3 dy dx plus of 2y is equal to cos square x. We can further simplify it, so it can be done. It is, so to simplify this we can do, it is d2y dz2 now minus of 3 dy dx plus of 2y, so cos square x equal to right is 1 minus sin square x. So this sin x we can write this as z, okay. So d2y dz2 minus dy dx plus 2y is equal to 1 minus z square. So there is a, you can write it equation 4. So to find the auxiliary equation, that is the, if we have to find the complementary equation, that is yc, okay. So to find the yc, so what is the auxiliary equation? So auxiliary equation is m square minus 3m plus 2 equal to 0. From here we can get m equal to 1 or 2, 1 and 2, these are two values are there. So what is the yc of z? A e to the power z plus b e to the power 2z, that is the complementary equation. And to find the particular integral, that is the yp. What is yp? So yp is equal to 1 by d square minus 3d plus 2 of 1 minus z square. So here you can do one thing, so it is half of 1 plus, so I just you just do this d square minus 3d by 2, okay. You just simplify it, actually nothing complicated. So this is this to the power inverse 1 by z square. So now if we expand the series, half of it is 1 minus d square d2 by minus 3d by 2, this is 1 plus d2 minus 3d by 2 whole square up to this, and the outside is 1 minus z square, okay. So from here we can get this half, so we have this 1, okay. So this will be 1 plus so half of, so we have this, it will be 1 plus, yeah. So this is 1 plus d2 3d by 2, so plus of it is d to the power 4 minus 9d square, okay, minus 6d cube. So we have to go up to the double derivative, right? So d2 at most. So this we have this 1 minus z square. Now further simplifying this, it's have to show all the steps, so it is quite elaborative. So now we will directly put this value, so it is half, and multiply this by 1 minus z square, so 1 minus z square. so it will be d2. So we have this minus 2 minus 3 of minus 2z by 2 plus 9 of minus 2 by 4, right? So from here you can get this is 1 minus z square, so plus of minus 2 plus 6z by 2, and this is minus of 9 by 2, right? So from here you can get half, so in the denominator it is 2 and in the numerator it is 2 minus 2z square minus 2 plus 6z minus 9. So from here you can cancel out 2 and 2. Okay, so what will be the answer? So it will be 1 by 4 minus 2 z square plus 6z minus 9, right? So what is the general solution? So general solution is y of z. So that is, this is the y of c. So y of z is equal to ypz plus ycz. So here it is yz is a e to the power z plus b e to the power 2z plus 1 by 4 minus 2z square plus 6z minus 9, right? So in terms of z it will be, so what will be in terms of z? The answer will be, this is in terms, and then in terms of x, what it will be? It is y of x is equal to a e to the power sin x plus b e to the power 2 sin x. Now it will be plus 1 by 4 minus 2 sin square x plus 6 sin x minus 9. So this is the required solution. The required general solution of equation 1 is y of x is equal to a e to the power sin x plus b e to the power 2 sin x plus 1 by 4 minus of 2 sin square x plus 6 sin x minus 9. So that is the answer. So that is the answer to the question 6b. So in the next, so it is quite elaborative and you can quite explanative. So you have to if you can answer in this manner, you will get the maximum marks out of it. That is the full marks you can get. So this is question 6b. In the next video we will solve with the next question, the next part of the question 6.